For decades, software development has relied on traditional application programming interfaces, APIs, as the universal handshake between systems. Designed as rigid, deterministic contracts between distinct programs, APIs require explicit endpoints, structured JSON payloads, and entirely predictable inputs and outputs. While this setup is perfect for standard software, it creates a massive bottleneck for modern artificial intelligence. Large language models operate probabilistically rather than deterministically, meaning they rely on reasoning rather than fixed instructions. Forcing an AI model to navigate traditional APIs is like asking it to find a document inside a massive, locked filing cabinet without any labels. To make it work, developers are forced to write extensive custom code, manage complex pagination, and engineer massive, brittle prompts just to teach the AI how to talk to a single endpoint. This friction is driving a fundamental architectural shift toward the Model Context Protocol, MCP, a new standard specifically designed for model-native software. MCP does not replace traditional backends or APIs. Instead, it sits directly on top of them as a semantic middleware translation layer. Rather than forcing developers to build bespoke integrations for every separate tool like Gmail, Jira, or Notion, an MCP server provides the model with a live, machine-readable map of the environment using self-describing JSON schemas. Armed with this context, AI agents can autonomously discover available tools, evaluate their capabilities, and dynamically reason about which functions to call and what inputs are required. This entirely eliminates the need for constant human handholding and heavy prompt engineering.
For developers, this shift marks a profound structural evolution in how applications are built. With traditional APIs, the logic dictating exactly when and how to call an endpoint is hard-coded directly into the application's infrastructure. MCP shifts this execution logic entirely into the model's own reasoning layer. This enables true plug-and-play interoperability, mirroring the revolutionary moment when HTTP standardized the web and replaced a fragmented ecosystem of isolated protocols. Instead of rewriting unique integration code for every combination of LLM and software application, developers only need to build an MCP interface once. From that moment on, any compliant model, whether Gemini, Claude, or GPT, can instantly discover, understand, and interact with those tools natively. Despite its massive potential, the road to widespread MCP adoption comes with early-stage hurdles. Because the protocol is relatively new, its ultimate success relies on ecosystem-wide adoption across servers, clients, and major developer frameworks. Furthermore, granting probabilistic AI models the autonomy to execute functions introduces serious security risks, such as accidentally wiping a database or firing off unauthorized emails. To counter this, the protocol is actively evolving to embed robust permission layers, scopes, and authentication methods directly into the specification. Ultimately, transitioning to MCP requires a major paradigm shift in the developer mindset, moving away from mapping static routes and endpoints, and moving toward designing systems around capabilities and context to build a truly model-aware future.